Welcome aboard, everyone. This is the first DB2 GSE session for 2021, and it's my pleasure, Colin Knight, to introduce Emil Kotrich from Broadcom, who's going to go into the joy of joins, and was going right from the basics up to more advanced topics and all about joins. So, a couple of things to remember. There's two charities we're supporting this year at GSE, and they are the Lifeboat charity and also the Guide Dog for the Blind charity. So please contribute that to those charities. They're very good causes. The links will be on the GSE websites. And also at the end, please do fill in the feedback, and we need as much feedback as we can get so that we can keep improving every year. And this session is 2AD. So without further ado, just one more point. Sorry, Emil, I'm keeping you waiting. Just one more point. Please put any questions on the chat and I'll keep monitoring that. And do you want to take questions at the end, Emil, or as we go along?
It depends. Some questions are good.
If they're difficult, we'll leave them to the end. If they're not, you take them as you go. Okay, we'll see how it goes. We play it by ear. Okay. But I'll keep monitoring that and we'll get to those questions one way or another. Okay, thanks everyone.
Thank you.
Over to you, Emil.
Thank you, Colin, for introducing me. Good afternoon, everybody. My name is Emil Kotrich. I work for Broadcom as an architect, as one of the architects for DB2 tools. I'm based in Prague, so I'm just 1 hour ahead of you. And this session will be about joins in DB2. So it's a DB2 session. And there were a couple of reasons for why I did this session. First, I thought that it's good to go back to roots and have some presentations about some stuff we all know, but still there are some things that maybe not very well understood or so. So I was hoping that this might be useful going from the basics to more advanced topics. And also in the past, I wrote some articles for IDAC. So, and I thought it might be good to turn them into the presentation. So part of my session is also from my blogs that I wrote for IDAC. I have references at the end of my session. So this is what Colin mentioned, the charity. So if you can, please donate. I think it's always good to help others. So use the link and more details. And now just to my agenda. Hopefully you can see and hear me well. If not, just let me know, but I will just continue. So this is the agenda. So I will start with history and theory, some basic terms. I'm pretty sure that we will know these terms, but still I would rather to remind some of them. Then I will talk about types of joins, or the basics, inner outer joins, we all know them. But then there are some other joins or other terms you may not heard before, so that I will speak about them. Especially what I found interesting are anti-join and lateral join. Then briefly about implementation of joins, because that's important to understand, I believe, so that you understand the next session, which is about some performance considerations. I will not talk too much about the performance itself and how to explain some joins and such, because that would be too much for this session. But I will speak about some considerations or some things you might want to be aware, especially how DB2 can transformate the queries, and it can also do some predicate manipulations. And that's important, I think, to understand for developers, how DB2 can optimize your query. Okay. And if you have any questions, as I said, it depends. Sometimes it's good to answer them in the session. Sometimes it's better to postpone. So we will see how it goes. Yeah, and this slide is important because a lot of what I have in my session, I learned from the experts. I'm pretty sure you have heard these names. So I just wanted to give them credit that a lot of things I have learned comes from these guys and others from their sessions or articles and so on. So, and I encourage you to visit their sessions if they have any, or read their articles, because you will not make a mistake if you learn from them. They are really great. Unfortunately, Terry Purcell, I don't know if you have heard, I think he left IBM recently. So that's unfortunate for our community. but still, I have some links at the end from Terry Purcell, from some of his articles. Anyway, history. Do you know where it all started? I mean, the relational model started in late 60s at IBM by research of Dr. Codd. And there was a famous article called The Relational Model of Data for Large Shared Data Banks, which really introduced the relational data model and also all the terms, or almost the terms you know now. And especially for this session, what's important, there was also mention about joins. So you can see this is a snippet from that article. You can find, I think I have the link at the end, or you can just Google for it. So this is where it started. And now I just some basic definitions. So what is really a join? Join is an operation that combines two or more tables and creates a join table, right? What we need to be able to join those tables is to have some join condition, which specifies the pairings, and some join operator, right? So that's what will happen with those rows. So three main things: join operation retrieves and joins data from two or more tables based on the condition, which is called join condition, and join type defines how the rows are formed if there is no match. Okay. Sometimes you will hear about composite table, outer table. So we have this outer and new or inner table. That's the newly accessed table in the stack. Then we will speak also about left and right table, depending whether it's on the left or right hand of the join operation. We will speak about null supplying table, which supplies nulls for outer joins, and also a term driver table, which is the data providing table. If you have a left outer join, it's on the left hand, it's a driver table, and on the right hand you have the null supplying table. Simple picture. We have two tables. We are joining them on that. The join condition is on those gray data. So we just have a new join table, which has a combination of those two tables. Simple thing. Hopefully this is all clear. If I speak too fast, just stop me, please. And this is how it works if you have multi-table joins. So we have the left table and right table. You join them. You have a composite table, the outer table, and then you are joining another table on the right, and then you have the result. Okay, so that's just how it works. So we can join more than one table. That's the point here. Okay, now let's jump into types of joins. There is an ANSI SQL standard which defines these types of joins. First one is the cross join, which is really a cross product of two tables without any criteria. It just all combines all the rows. Then we have inner join, which is a cross product, but it keeps only the rows where the join condition is true. So now you need to have some join condition. And then we have outer joins that add some additional rows where there is no matching rows. And now we have three types of them: left, right, and full. I will describe them later, so I don't need to go into details. And then I will talk about other joins: anti, equinatural, self, and lateral. So you will see it in the next slides. So let's start briefly with the cross join. So as I said, cross join is basically a cross product of the tables. So each row of the left table is combined with every row of the right table. Most often this is not what you want, but there are some use cases where you want to do the cross join. So basically the number of rows in the result table will be multiplication of rows of both tables, right? In DB2, you can use two syntaxes, or two syntaxes are available. You can see them at the bottom. The first one explicitly speaks about the cross join. So there is a cross join keyword you can use, or you can just do select from A, B, which will do a cross join of table A and B. So the good practice here is to use the explicit cross join clause, because then it's really clear that you want to do a cross join. If you have it without, as on the bottom line, then maybe it looks like, hey, you are missing some where condition, right? So better if you really need a cross join, because not very often be explicit. Okay, just a visualization. It just combines all rows from the left and right table. Inner join, it's the main difference here is that now you must have a join predicate, right? So compared to the cross join, now we have a predicate, and we will only, the result will be only the rows where the join condition is true. Now, order of the tables doesn't matter. So it doesn't matter if it's on the left or right hand. In this case, it doesn't matter. And also order of the predicates doesn't matter. And what's important, here there are two available syntaxes. The old one is using the where clause, or the new one, which is using the join clause. Okay, a simple visualization, I can skip that, I believe. It's all clear. In this case, we just join the tables on the orange, right? So we'll just have one row here where the condition is met. Now, I mentioned two possible ways how to code inner join. So on top, you can see the older standard, which is all is coded in the where clause. So you just do a select from department and employee table. So you just have them comma separated in the from clause. And then in the where clause, you specify the join condition. The newer syntax, which is at the bottom, into flavors, has explicit on clause where you specify the join condition and has the keyword join in the from. So then you can see that this is really a join. We are joining department and employee table, and join condition is where the department number of the department table equals to employee work department. So in this case, the result will be the list of departments with the employees that work in these departments, right? And as you can see at the bottom, there are two options. You can just code join, or you can even code explicit inner join, but that's the default. So if you just type join, inner is explicit, or implicit, sorry. So you don't have to code it, but maybe you can even use this more verbose syntax. Important thing, how inner join and filtering work. So in this case, in this example, I have two conditions. One of them is join condition. So I'm joining again department and employee table using department number and work department. But I also have a filtering clause. And I want to see just the departments that start with D. Now, for inner joins, it doesn't matter if I code it in the where clause or in the on clause. So the result will be the same. But keep this example in mind, because once we talk about outer joins, there is a huge difference of join condition and filtering condition. In this case, you can see there are two options available. On top, we have this older syntax where everything is in the where clause. So I am joining department and employee. And in the where clause, I have the join condition and also the filtering predicate. While on the syntax below, I see the explicit join keyword, and then I have on clause, which contains the join condition, and then I have the where clause, which specifies the filtering. Personally, I prefer the bottom one because it's pretty clear what's join condition and what's the filtering. But I know that in many existing code, maybe the older syntax is currently being used. Also, as for the examples, as you can see, I'm using this department and employee table. So I use, in all examples in this slide deck, I use the IBM samples that are shipped with DB2. So you can even play with those examples. I hope I tried all examples that they are working, but rather try it. That should be working. Now, outer join. So it was introduced in DB2.4, and that's interesting because then I was thinking, hey, how did you do it if you want to do it before? Because I guess there were use cases for outer joins even before they were implemented in DB2. So before that, you had to combine inner join with union and not exist kind of thing. So you had to most likely have some with inner join and then combine with union with the rest of the rows. Inner joins, outer joins, sorry, can be in three flavors: left, right, and full. And the difference is how how the non-matching rows are presented in the resulting table. So first, the result table will contain the matching values, which is the same as if you do just the inner join, plus also the unmatching rows. Now there is only one syntax available, so you must explicitly code the on clause for the join predicates, and the filtering predicates must be part of the where clause. I will show you an example if you do it differently, what happens. And now order of tables is important. If you do left or right join, it's kind of obvious that the order of tables is important, which one is on the left and which one is on the right. Okay, this is a nice example or nice diagram from DB2 documentation. I just copy pasted because I think that this explains what's the difference between left, full, and right outer join on this diagram. So this is pretty cool. I try to visualize it here as well, but I'm pretty sure you kind of understand. So what I have here, I have A, B, C. So B is where all those join conditions are met. So that's the inner join. Then if you speak about left outer join, then we will have rows from A, and even if there is no match. Okay, all right. So now let's talk about left outer join. So now the driver table is on the left side, and the null supplying table is on the right side. Why null supplying? So it means that when there is no match on that row, the right table will just supply the null values for those columns. Example at the bottom. So what we are doing here, so we are joining department and employees, but compared to the other example, we are doing left join instead of the inner join. Well, what does it mean? So what's the difference here? So apparently we want to see departments even if there is no employee working in those departments, right? So that's what we will see in this report compared to the prior one, because in the prior one we will just see only departments that have some employees. Now we will even see departments that don't have any employees. So we will see those departments, and on the right hand, if there is no employee, you will see those null values for employee name, employee number, and so on. Right outer join, very similar. Now we just swap the sides, right? So driver table is on the right hand, null supplying is on the left side. So as you can see, I have exactly the same example. I just switch the side, so department is on the right hand, employee is on the left hand. Now what's the purpose of this left-right join? I guess the main reason is readability, because in fact there is no performance or any other difference between left and right outer join. And in fact, even if you code right outer join and then you do the explain, you will see that DB2 will just treat it as a left join. So in the explain tables, you will see that this is the left join, but the tables will be switched, right? So we will see the department on the left side and employee on the right side. Full outer join is a bit different. So in this case, driver and null supplying tables are on both sides. So you have inner join data, then you have like the left outer join data, but also the right outer join. So now it contains everything. So I think we are comparing or joining department and employee, but now now the join condition is different, I believe. Now we are joining on manager, right? So manager of department and assigning to employee. So now we will see all departments that have some employees. We will also see departments that don't have employees, that will be the left outer join. And we will also see employees that are not managers, that's the right outer join, right? So that's the difference here. Now I mentioned that, and that's the important thing here, outer joins and filtering. As I mentioned in the inner joins, filtering can be part of the on clause on the join condition. Now, and that it doesn't matter. Now in this outer join, that makes a big difference. different. So let's see what I have, for example, here. So in the first case, I have the filtering on the where clause. So what I'm doing a left join of department and employee. And again, I'm looking for a matching on department number and working department. So I will do a join of departments and their employees. And I'm only interested in those departments that start with D. Okay, and this is what I have on the top example. So join condition is in the on clause and filtering condition is in the where clause. While if you look at the bottom, now I have, what's the difference? Now the filtering that was in where clause is now part of the on clause. So what has changed is that now it's no longer a filtering condition, but now it's part of the join condition. Let's see the output so that you can imagine what happened. But the important thing to understand here is that this is no longer a filtering clause. So in the first example, you can see that I see only those departments that started with D, and I joined them, left joined them with the employees. So for the first department, there is no employee. That's fine, because I wanted a left join. But then I see just those departments with D. While the second example joins on all departments that start with D, but it doesn't provide any filtering. So that's why I see all the departments, but I don't see any last names for other departments than those with D, because that was the join condition. Let me go back. So as you can see, the condition was that I'm joining department number with working department, and department number is like D, starts with D. That's why this condition only joins the departments that start with D. Most likely this is not what you want. That's why you must be careful. And also, if you let me go back once again, that's why I mentioned that it's a good practice to code the filtering condition in the where clause specifically even for inner joins. And the reason for that is that sometimes you have an inner join and then you change it later for outer join. And you may forgot that you should change the filtering to not be part of the on clause, but be part of the where clause. So that's why it's important to make it more readable and clear, even if you do changes in the future. Okay, some brief slide about join conditions for inner left and right. Can be any storage condition. For full outer join, there are some limitation, can be only equal combined with AND. All right, so far so good. How we are on time? Oh, 24 minutes. I'm sorry, I have busy slides, so I will continue unless there is any question. So let's go on with those next or other joins that are not part of the syntax, but kinda are extension of or just additional terminology. So what is a self join? So the join itself doesn't prevent us from joining the table to itself. So you can join the same table more than once, no big problem. Why would you do that? There may be different use cases. For example, you might have a self-referencing foreign key, and I will show you an example. You may want to compare to other rows in the same table. Again, I will show you an example. Or maybe that's just a use case. Maybe you really need to join a table multiple times. Have an example. So this is example if you have a self-referencing foreign key. Excuse me. Nice example here is the department table of the IBM sample tables, because in the department table, there is a column that points to administrative department. In other words, to the department that manages the current department. So, and as you can see, I want to see the managing department of the current department. So that's why I'm joining department table twice, right? So I see, as you can see in the join condition, I have department as D1, joining with department as D2, and the join condition is administrative department equals to department number. That's why I will see department administrative department for every department in my company. Another example, now I'm comparing two different rows in the same table. what's the use case here? So I have an employee table and I want to have a report that shows me employees that have higher level, education level, but have lower salary than other colleagues, right? So that's what I do. So that's why I'm joining the employee table twice. And my join condition here is on education level and on the salary. Okay, so I'm comparing really the rows in the same table. And what if I really need to join a table multiple times? And this is an example. I'm joining multiple tables, and what I do here is I'm doing a report showing all departments and the projects the department is working on. And for the department, I want to see its manager, and for the project, I also want to see its manager. And those managers for project and also for department are coming from the employee table. So that's why I joined the employee table twice in this report. I think it's pretty obvious, just looking into the same table for two different purposes. It might be the same person, maybe it's not, but it doesn't matter. Okay. Sometimes you may heard about equijoin. No special syntax, no anything. It just sometimes referred as a join where you have just equal predicate in the join condition. Examples below, no magic, really just a term. Natural join is a bit different. There used to be a natural join in the standard. I think it was later removed from the standard itself, but still some database management systems still support it. As far as I know, Oracle and maybe even Postgres. DB2 for ZOS doesn't support this syntax, but of course it supports the natural join. And what is the point here is natural join provides you an implicit join condition, and it's comparing the same named columns in the both tables, which is kind of confusing because then you need to know the names of the columns. So if you look at the bottom on the left hand, you see the natural join syntax. So there was really a keyword, natural join. So now I'm doing like natural join of department and project. And these tables now need to have the same named column, which will be joined. And this syntax is not supported by DB2. On the right hand, you can see how you would code it in DB2. And the difference is that you would just explicitly code the join condition. As you can see, the column name is the same, but I just explicitly coded it here. For readability, I think this is definitely better than relying on this natural join. But in some systems, this is still supported. One thing here, so you can write the natural join even for outer joins as well, and no big magic, just using the same name column. But what can happen? Let me go to the next slide. What can happen if you look at the top box? You see that now I have the same column, so I'm doing the outer join, and I have the same named column in both tables. And because I'm doing the full outer join, sometimes I have the value, sometimes I don't. So I would like to collapse this column into a single one, right? So that's what you may want to do, to have just a single column for department number. So if you let me go back one slide, you can see that I was just using this coalesce keyword, which means that it will just print or output the non-null value of these two. That's just a simple trick that can help you make reports easier to read. Anti-join. Not sure how many of you have heard about anti-join. I've learned about anti-join from Dan Luxetich, specifically from one of his article. And this is kind of nice technique. And it can be an alternative way of doing not in or not exist subqueries. And the reason why you would code it with anti-join rather than subqueries is that joins can perform better, especially for large data. Of course, this is not like a general rule. Mileage may vary, but later I will explain why this is possible, that DB2 will perform better if you do a join. So what is anti-join? So it's basically an after join predicate in outer join to filter data based on the fact, I don't want to read that, and the relation between the two tables doesn't exist, which means basically that anti-join is a predicate looking for the null values. So you do the outer join, and now you just want to take a look at the rows that don't match the condition. Basically, you will take a look at the null values. Example will be better, I guess. So in this report, I want to display all employees that do not work in a department that start with D. Now, I have multiple ways how to do it. As you can see on top, I have a not in predicate, and I have a non-correlated subquery, right? So I do this select, and I select all departments start with D, and then I do the select from employee table, and where the working department is not in that list. So that's the first example. The second example is using correlated subquery. I'm using the not exist, and you can see I'm just when doing the select for that employee, looking in the department and whether it starts with D. Okay, so this is how I can do it using subqueries. How I can do it with the anti-join. So you can see it at the bottom. I am joining employee and department table, obviously. And I'm doing left join. So I'm doing employee, left join department. So I will see all those employees that work in this department. And in this case, I have the department name like D predicate even as a part of the join condition, because I want to join only on the departments that start with D. So this is not a filtering in my case, but really a join condition, right? So this must be clear. But my filtering condition is where D department is null, which means it's coming from the null supplying table. So there was no match from employee and department. And do I have it? Oh, sorry, I don't have the output here. But what you would see here is a list of employees that do not work in departments that start with D. Kind of nice technique, and pretty cool. And later, as I said, if I have time, hopefully we'll explain why this may perform better. Lateral join. A short story behind. There was a few years ago, there was a new version of Postgres SQL, because time to time I monitor what my MySQL and Postgres, what they are doing. And they introduced this lateral join. And I was like, okay, what's that? And let's try it in DB2. Is it there or not? And they used sort of this example. I want to show all departments and 3 employees within each department with the highest salaries. How you could do it? So I just coded this simple SQL, this simple query. Right? That's what I thought. Okay, this will do the job. Then I submitted, and I got this error. Right? The department number is not valid in the context where it is used. So now let me go back. So you can see that's the highlighted thing. So I have this select in the from clause, but I cannot, for some reason, I cannot reference department number, which is on the same on the same level, right? So in this query. So then I dig deeper into the documentation, and I found out that there is this table keyword. So you can see there is the only difference between this query and my original query was that before that inner select, after comma, I added this table keyword. When I did that, look what I got. I really got the report I wanted. For every department, I have listed top 3 employees with the highest salary. So the matter here was really about the table keyword. So if you look into the documentation, you will learn that by adding table keyword, which is also known as lateral correlation, DB2 allows a join of table or nested table expression which are on the same level. And this is really what is called lateral join, that you can query table even if it's on the same, or you can reference the table in the on the same level. So you can see at the second paragraph at the very bottom, if you don't use table, only references to higher levels in the hierarchy of subqueries is allowed. So that's the difference. And now DB2 for ZOS allows only this table keyword, which was, by the way, introduced in DB2.6, which was a couple of years before Postgres did it, and when I learned about that, and in DB2 LUW they even allow this lateral. So you may even see queries which contain this lateral keyword, which is not, or as far as I know, it's not currently supported in DB2 for ZOS, but it's just a matter of changing it to the table keyword. Semi-join, kind of similar to this natural join, but in this case, tables are not joined, but just checked for a join condition. So I would say maybe even more similar to anti-join, but this is really not a anti-join, but just a check of existence, right? So in this case, I have example at the bottom. I am selecting employees that work in any department, right? So, and what I can do instead of this subquery, I can code it as a join and just have its join condition, but I'm selecting only from the employee table and I don't care about the department table. So this is yet another technique how you can rewrite your subquery into a join. Okay, this is interesting. I'm unmasking the mask data. DB210 introduced column masks. I don't know if you are familiar with them, but they allow you to mask some data. If you do some select, the data can be masked. So this is a simple example how you can do it. So I have employee table and I want to mask the bonus column. So as you can see, it's simple expression. I define the mask, and when the bonus is higher than 500, then I want to provide null. Otherwise, just give the bonus. Then you do the alter table employee, activate column access control. When you do the select of the employees, you will see this thing. So for those that have bonus less or equal to 500, you will see the bonus. But for those that have higher, you will see the nulls. So, and we discussed this feature with one of my smart colleagues, and he was like, all right, but it's simple to get this data out because you can join the data, right, with other tables. So if you can join that, you will find the matching values, and that's it. And really, that's a bright idea and pretty simple. So what I did, I just wrote this simple query. It looks maybe too complicated, but it's really simple. On top, I use the common table expression and just create a simple table of numbers starting from 1 to 30,000 in my case. And then I join this table with the employee table, and my join condition is the bonus equals to the number, right? And now I can just display the unmasked bonus as simple as that. So I just joined with that employee table with my hack table. So, and I wrote an article about this one because I think you need to be careful when using column masks. Apparently, this is pretty simplistic example, right? You not always want to mask just the simple numbers. So for names or whatever, it might be more tricky, but still you can enumerate and join with other with those enumerated values. So really be careful with those column masks, and think that people can be very creative as in this example. Okay, all right, we have 20 minutes to go. So jump to the next section, which is about implementations of joins. This is what DB2 does under the hood. So when it needs some algorithms how to perform the join, right? How to actually do the join. So this is just a reminder. We have multiple tables if needed, and we just do the left, right, and so on, right? So this is the process. Now there are these 4 common algorithms how to perform the join: nested loop join, merge scan, hash join, and hybrid join. The reason why I speak about this is that you can see that DB2 has multiple options how to execute the join. If you compare to the subquery, for example, if you do the correlated or non-correlated subquery, DB2 doesn't have that many options how to do that. While if you rewrite that to a join, DB2 can select between different join methods depending on the statistics, on the indexes, on the data volume, and so on, and will pick up the method that would perform better to DB2 knowledge using the statistics it has. So nested loop join, I will go through it rather quickly. So nested loop join is kind of what you would think, or maybe that's like what you would do if you do a knife implementation. So you have two tables. So you take a look at the first row here, you scan the other table, and you find all the matching rows, right? If you are doing outer joins, you will just grab the row, and if you don't find anything, you will supply nulls, and that's it. Then you go to the next row here, and you scan the table again, and so on. So that's how it works. So which means that the inner table can be scanned repeatedly, right? So we just go here from top to bottom and just scan. So when this is used, usually when the outer table is small, so that it limits the number of loops here, right? Or if there is, or if just the qualifying number of rows is small on the left. So maybe the table can be big, but maybe the number of qualifying rows is pretty small. So we will just do a couple of loops here. DB2 can even sort the outer table under certain conditions and so on. What's specific to DB2 for ZOS is the usage of sparse index, because DB2 for ZOS at the moment doesn't have any hash join implementation, or the hash join as we know it from other platforms, but they can use this sparse index. And since DB210, they support also they provide some hashing support in DB2, which is kind of comparable to the hash join. So in this case, it's just the optimization, how DB2 can process the nested loop join with the sparse index, which is an index pointing to a range of number of contiguous rows rather than a specific grid. So it just has a blocks of rows. All right, so this is just a visualization how it works. So you have this left table, you go from top to bottom, and you repeatedly scan the other table. Merge scan, that's the second method, works a bit differently, and it really reads both tables from top to bottom. What it needs, it really requires the tables to be either sorted or have some indexes, right? So depending on your join condition, if you have a condition which uses some index, DB2 can be pretty efficient and read the data in correct order. Or if it's not possible, DB2 can even sort the tables if it's needed. In the explain tables, you could see there is a indication whether the data will be sorted or not. How it works for unmatched rows. So if it's for inner join, data is discarded, and if it's for outer joins, it depends whether it's left or right. When this is used, when you have one or more equi predicates with the equal, and especially for large tables, and maybe some other use cases. So again, this visualization just shows that it reads from top to bottom. Hybrid join. There was a nice article about the hybrid join, because this is really very different than those other methods. So it requires an index on the inner table, because it really works into phases. In the first, it just joins the outer table records with the index on the inner. Then it does the sorting of the reads, and then it retrieves the data from the inner table using the list prefetch. So especially this is very useful if you have a non-clustered index, right? And it helps to avoid those random reads. So it really does the list prefetch and reads the rows in order. This is what I wanted kind of visualize here. You have the left table, and on the right you need to have an index, so it joins the data with the index. then it does the join with the data itself, and then you have the result. Hash join, this is not available for DB240S, but as I mentioned, DB240S equivalent is nested loop join with sparse index and hashing. So I will skip that. This is for DB2LUW. So, and in this case, you need to have some hash, which is on that green bar. So you calculate the hash in both. So first you need to build a hash, and then you calculate the hash for the rows and see whether the hash matches or not. Okay, star joins. Personally, I don't have any experience with star joins. I know there are those two options. So there is this star joins. So you have this fact table and multiple dimension tables. And in the star join, it requires a single table on fact table that supports filtering on the dimension tables. There is this second flavor, which is called pairwise join. And the difference here is that this requires separate indexes on the fact table and individual dimension tables. But as I said, I don't have much experience with that, so that's just what I've learned from the documentation. Join predicates. So we have 15 minutes or so. So far, so good. No questions. Hopefully, it's not too fast nor boring for you. All right, let's go into join predicates. Again, some basic stuff about how DB2 performs the queries. I don't want to go into those different layers in detail, but on the left-hand left top, you see the request is coming to DB2, comes through the different layers, and then you get the response back. So at the very bottom, you have just the data on the disk, right? So, and there are multiple layers where DB2 performs some actions. So sometimes you have heard about those indexable stage 1, stage 2 predicates. So this is visualized here. I won't speak about them into detail. So just for your reference, I will even skip these things just for your reference. But what's important for this session is what predicates you can use in the on clause. So I mentioned that for outer join, it can be a join condition. For inner join, it can be join and also filtering, while still would be prefer to use it in the where. And maybe one more thing here. What's the sequence of the join operations? Because I think people are asking, hey, does it matter if I code this first and then this predicate? So yes, in some cases it does, but still DB2 optimizer is getting smarter and smarter, so it can reorder the sequence of the multi-table join depending on the cost. So if you do the explain, you might be surprised that, hey, but this is reordered. So don't get confused. DB2 is really trying to optimize the query as much as it can. So the point here is that the join sequence is not necessarily the same as order in which you code them. Now, what can be the join predicates? And this is kind of obvious when you think about it, but not always obvious when you just code it. So we can think about these types of join predicates. The first group is before. So these are the predicates in the where clause, and they help you to filter out the rows you don't want to join. Then you have some during predicates that are really DB2 is executing them during the join. And then you might have after join, after stack join, or even after join totally, after join. Some examples. So this one is example of the before join. Right? I'm joining two tables, T1 and T2, simple equal predicate, and I have the where clause where the column 2 of T1 is greater than 100. So this clearly can happen before the join because it helps to remove all the compares performed during the join. So good practice is always code filtering predicates, right? Because they are before join and they help you to reduce the amount of data. Then this during join predicate, we have left outer join here. And now DB2 doesn't know until it really joins with the row whether it is matching or not, because if it's null or not, right? So now in this case, it really needs to do it during, if it's there or not. Then after join step predicate, what is here? Yeah, so this is just an after step. So in this example, once we join department and sales, it can be applied after we really match those two rows. And if you take a look at this totally after join predicate example, this is what can happen at the very end, because we join 3 tables: employee, department, and employee project table. And we are looking whether the last one is null, so which means there was no match. So this is really totally after we do all the joins. Okay, sorry, that was very quick, but I wanted to jump into this this last section, which will show you some manipulations and transformations that DB2 can do. And that might be sometimes confusing when you do the explain. So in general, DB2 can modify predicates. It can generate some extra predicates or remove. And it can even convert some of the queries. So it can transform subqueries to joins. It can add extra predicates, and it can even change the join types if it makes sense and would produce the same results. So all these manipulations will give you the same results, right? So that's the point. It will not, unless it's a bug, obviously, but the point here is that it will provide the same result, but more efficient. So for example, I have on the top example, I have example of how DB2 can change your outer join to a left join. And what's the point here is that in the where clause, we really speak about x.c2 is higher than 12, which means it's not null, right? So it may not be coming from the null supplying table, which means that we are really doing a left join. Well, if you think about it, you should code it since beginning, but maybe you just missed that, or maybe you changed the conditions, so we didn't change the join type. But then if you do the explain, you can see that this is really left join. Similar to example below, we have right outer join, and DB2 can transform it to the inner join, because again, we are querying or we are filtering on the data which are not null, right? So in this case, it needs to be an inner join. DB2 can also add some extra predicates, and you would see them in the predicate table after you do the explain. So this is called transitive closure. And again, this is kind of obvious. Maybe good practice would be to code them explicitly so that you can clearly see them. But what's the point here? So at the top, you can see, hey, my join condition is on the column 1 of table 1 and table 2. And I also have this filtering that table 1, column 1 needs to be greater than 10. But if you think about it, they need to be the same with the table 2. So now I can clearly add the second condition as well. Example below, maybe not that obvious, but the same case really. I'm just adding the DB2 can add the where clause, because really the join condition is on the equality. And this is more interesting, how DB2 can transform a subquery into a join. And I was speaking about the anti-join or semi-join, how you can transform subqueries into different joins. So this is how DB2 can even do it under the hood for you. So in this case, what are we doing? So we are selecting employees that work in departments that are located in San Jose on San Francisco, and division is marketing, right? So DB2 can rewrite this into a joining employee and department. And as you can see, there is a filtering predicate. The division must be marketing, and department location must be in San Jose and San Francisco. And the join condition is department number, employee, and department number in department table. Another example. So here on the right hand, I have two subqueries. One of them is again correlated. The other one is non-correlated. And on the left hand, oh, sorry, what happened? On the left hand, you can see how it can be written into subquery. Okay, so joining employee and project table, we are interested into project that is with this name, and job needs to be designed. So I have two filtering predicates. One is on the employee, I guess, and second one is on the project. And I'm joining department again here. All right, we are almost at the end. So I have some references here. If you are interested, there are some articles, as I mentioned. So I hope you enjoyed. These are our twin boys. So hopefully you enjoyed as much as they did. Thank you for attending my session. If you have any questions, you can ask now, but we have just 3 minutes or so. Or you can even send me an email. I will be happy to answer any questions you might have. Or most likely, I will send you some more information or some links where you can learn more. So thanks again for joining. And if you have time for any questions, I'm ready to take it. Thank you.
Thanks, Emil. I can't see any questions coming up on the chat just now, but you have just 3 minutes left. After this session, there is a 30-minute break for coffee. And
oh, really? Is it?
There is. So yeah. So don't forget to get a coffee and have a break, and come back for sessions after from 3:30. Yeah, please do provide feedback to all these sessions. This session is 2AD, and you can do that by following the link on your agenda. And we just have a question here coming in from Hitesh. Are there any slides for this to distribute to all?
Yeah, I think the slide deck is available at the download, right? If you click on
that's right. Yeah, there is a link on the agenda again, and slides will be available. If not right today, then they will be available within the next day or two, I believe. But certainly they will always be available at some point after the session.
And I checked today morning and it was there. So
oh, it's already there. There we are. Oh, in fact, somebody's already downloaded them. Steve has downloaded them, so that works. So okay, they're already available, all ready to go.
Thank you for confirmation.
Thanks, guys. Okay, so there doesn't seem to be any other questions at the moment, and it's just about a minute to go. I will probably close it down there. Please do support our two charities for GSE, the RNLI and the charity for the Guide Dogs for the Blind. And okay, of course, good slide there as well. There's a couple of things there. So do become a member of the GSE UK if you're not already a member, and you get all these benefits. Yeah, and there's details there about how to get more details about joining. Okay, so thanks very much for your attendance today. There aren't any more DB2 sessions today, but there's plenty of other things coming up after 3:30. And there's actually a quiz tonight at 8 o'clock. So I'll be in that, I think, with a bit of luck. So thanks very much, everyone. We'll see you again in another session soon. Thank you.
Thank you. Have a nice day.
Thanks, Emil. Well done. Good session.